Imagine you have two computers, A and B, connected to the same network. Computer A has an IP address of 192.168.10.1, and computer B has an IP address of 192.168.10.2. You can successfully ping computer B from computer A by using the IP address. Suppose you know that computer B is running database services and you prefer to refer to it by a more memorable name like DB, instead of remembering the IP address. To make this work, you need to inform computer A that the name DB corresponds to the IP address 192.168.10.2. Here's how to do it. On computer A, you can edit the /etc/hosts file. This file is used to map hostnames to IP addresses. Add an entry with IP address 192.168.10.2 mapping to hostname DB. After adding this entry, when you ping DB from computer A, it will correctly resolve to IP address 192.168.10.2 and the ping will be successful. The /etc/hosts file acts as a local address book for computer A. It tells computer A that whenever it encounters the name DB, it should use the IP address 192.168.10.2. However, computer A does not verify whether computer B's actual name is DB or not. It simply trusts the information in the /etc/hosts file. You could even mislead computer A by adding an entry that maps the IP address 192.168.10.2 to a different name, such as www.youtube.com. As a result, if you ping youtube.com, you would receive a response from computer B instead of the real YouTube servers. The /etc/hosts file can contain multiple entries, mapping various names to IP addresses. This means you can have several names for the same IP address, and computer A will use the information in this file to resolve names to IP addresses whenever needed. In a larger network with many systems, managing the /etc/hosts files on all machines becomes impractical. Instead, you can use a central DNS, domain name system, server to handle name resolutions. This way, if you change the IP address of a server, you only need to update the DNS server rather than every individual machine. To point a computer to a DNS server, you update the /etc/resolve.conf file with the DNS server's IP address, such as 192.168.10.100. After doing this, the computer will query the DNS server to resolve names to IP addresses. If the DNS server is updated with the new IP addresses, all systems will automatically get the new IP information. However, if you only need to resolve names locally and not for the entire network, you can still use the /etc/hosts file. For example, you might add a local entry for a test server that is not known to the DNS server. If you have an entry in both /etc/hosts and DNS, the local /etc/hosts file takes precedence. The order of resolution is controlled by the /etc/switch.conf file. By default, it first checks the /etc/hosts file before querying the DNS server. You can change this order if needed. If you attempt to ping a name not in either the /etc/hosts file or the DNS server, the request will fail. To resolve external names like www.facebook.com, you can configure your DNS server to forward requests for unknown names to a public DNS server, such as Google's 8.8.8.8. Domain names are structured hierarchically. For instance, www.google.com is broken down into the root of the domain hierarchy. .com, the top-level domain, TLD, which indicates the type of organization, commercial in this case. Google, the second-level domain, which identifies the organization. www, a subdomain, used for a specific service under the main domain. When you query a domain like apps.google.com, your local DNS server might not know it and will forward the request up the DNS hierarchy to resolve it. This process involves multiple DNS servers, root servers, TLD servers, and authoritative servers for the domain. To improve efficiency, DNS servers cache responses for a set period. This caching avoids repeating the entire resolution process for frequent requests. Your organization's internal DNS server can handle its own domain, such as mycompany.com, with subdomains like www.mycompany.com for web servers, mail.mycompany.com for email, and so on. If you want to simplify local name resolution, you can configure the search directive in the /etc/resolve.conf file to automatically append your domain name. Finally, DNS records come in different types. A records map hostnames to IPv4 addresses. Quad A records map hostnames to IPv6 addresses. CNAME records alias one domain name to another. For DNS testing, tools like nslookup and dig are useful. These tools query the DNS server directly and do not consider local /etc/hosts entries. nslookup provides basic details, while dig offers more comprehensive information about DNS records. That's all about this tutorial. See you in the next one.